Today we're going to be talking about some properties of proportions. So a proportion can be written, remember, as two ratios. So A to B is to C to D. So writing these as fractions, A to B is equal to C to D. There's some special words that are going to mean something to us in later chapters, but B times C, these are the means. We're going to be talking about geometric means in later chapters, so that's why I like to bring this up now. Those are the means. These, A and D, are the extremes. And remember, a good way that we can clear the fractions is we can do what we call as cross multiply. A times D is equal to B times C. So some different properties of proportions. And when we are writing these in a proof, our reason is going to be property of proportion. So first we have our first um, initial proportion. A to B is equal to C times D. So A would be just cross multiplying. Okay, I just cross multiplied. Again, remember our reasoning in a proof is property of proportions, but you guys are used to seeing that first one, A, as cross multiplication. The next one is you take the numerators, one numerator over the other. We started with A over C, so that's why we have to do B is equal to B over D. You could also think about this as if you take A and you divide both sides by C times D, that gets us part B. Same thing with C, just now I'm dividing by A times C from part A. D is if you take the denominator and you add it together, add it to the numerator, you get the same fraction. So say I have 3/4 is equal to 9 over 12. If I take 3 plus 4 over 4, that's still going to be equal to 9 plus 12 over 12. And that should work out. Number two, or our second property of proportions is if A over B is equal to C over D is equal to E over F. So if you have a bunch of different ratios that are equal, you can add together all the numerators and all the denominators, add together all the numerators, all the denominators, and that's going to be equal to A over B plus C over D plus E over F. So all those are going to be equivalent ratios. So just looking at first some properties. So if I have 5 times A, well, let's think about what I did. We did our cross multiplication. 5 times A, so that's going to be equal to 3 times B. Now looking at B, I have 5 over B, that's going to be equal to 3 over A. Let me make that look like an A. Now I have, remember our initial proportions, A over B is equal to 3 over 5. For C, I took and I added the denominator to the numerator. So if I take and I add 3 plus 5 over 8, that's going to be equal to 8 over 5. That denominator doesn't change. And D, I just took the reciprocal, so 5 over 3 is equal to B over A. Really in this section what we're going to be doing is we're going to be solving proportions. So solving for x, we'll do 3 examples where we're solving for x. What you want to do is you want to cross multiply x times x is x squared. Then take and cross multiply the other way. X minus 2 times x plus 3. Now simplify. X squared is equal to x squared minus 2x plus 3x happens to be an x minus a 6. If you get get rid of your x squared. So if I subtract x squared from both sides, you get 0 is equal to x minus 6. Add the x over, x equals 6. Now you always want to do a check. Does that 6 make either the denominator 0? Doesn't make either denominator 0, so we are good, because the only numbers that can't have in the denominator are 0 and negative 3. The next example, again, let's cross multiply. 10 times x plus 2, so I have 10x plus 20 is equal to x minus 1 times 3x minus 2. So let's multiply out the right side. This ends up being 3x squared, a minus 3x, and a minus 2x is a negative 5x, plus 2. Whenever you're solving a quadratic, get one side to be 0. So I subtract the 10x over, so I get negative 15x. I subtract the 20 over, that's a minus 18. Whenever I see a number in front of the x squared, first I see if I could factor out that number from each term, and it works out nice and convenient that I can factor out the 3. Now factor the trinomial. Two things that multiply to be a negative 6 but are going to add to be a negative 5. Well, let's look at this. Negative 6 times 1 and 3 times 2. If I make both of the 3 and the 2 negative, yes, they're going to add to be a negative 5x, but they're not going to multiply to be a negative 6. They're going to multiply to be a positive 6. So this is our option, x minus 6, x plus 1. Then set each one of the factors equal to 0. You don't have to worry about the 3 because there's no variable attached to it. We just set the x minus 6 equal to 0 and the x plus 1 equal to 0. And we get two answers, 6 and negative 1. 6 doesn't make the denominators equal 0, neither does negative 1, so these are both our answers. Our last example involves x's and y's. So whenever you have two variables, you need to get two equations with two unknowns. We have two equations, we have two variables. Let's get rid of these fractions first of all. So I'm going to cross multiply here and get 4y plus 8. I'm going to cross multiply there to get 2x minus 6. I'm going to get the variables all on one side. So I'm going to write this as, I'm going to add these 6 over so I get 14. 2x, I'm going to subtract the 4y over. I notice that 2 goes in each and every one of those numbers, so I'm going to divide each term by 2. Let's deal with the other one because I have an equation, I have two variables in there, I need another equation. So I'm going to cross multiply and I'm going to multiply by 5 to get rid of the fractions. So I get 5x plus 5y minus 5. Cross multiply the 6 over, I get 6x minus 6y plus 6. I'm going to get the variables all on the right side. I get the numbers over, so I'm going to subtract a 6 over to get a negative 11. I'm going to subtract the 5x over to get an x. I'm going to subtract the 5y over to get a negative 11y. So if I add the 11y over, I have x equals 11y minus 11. Since I can solve for one variable here, I can just take and substitute that in for x. So we end up with 7 equals x, substituting in from the other one, 11y minus 11 minus 2y. Now I have an equation in only one variable. If I add the 11 over, I get 18. 11 minus 2 is 9y. Y is going to end up equaling 2. I needed to solve for x and y. Substitute back into one of your two equations. Substituting back into the 11, y minus 11 makes the most sense, so I have 22 minus 11 is going to equal x. Thus, x equals 11. Here are your lesson questions for today. Please make sure those answers are submitted on time.